again, 2 days in a row. Holy cow. You're probably sick of hearing my voice already. But the good news is this will be it for the week. But I hope these are helpful, and I am going to be doing more of these. And maybe, just maybe, if you're lucky, you might just see my face in one of these upcoming lessons. Um, so the assignment, they were rolling in. Period 1, 2 did pretty good of emailing me your responses, but I'm still missing roughly half of you yet. But the day is still young when I'm doing this right now at about 2 o'clock on Thursday. Period 7, 8, you gotta pick it up a little bit. I'm missing a lot of your responses to this, so make sure you do that because that gives me an idea of where your thinking is and also helps me focus in on what questions we need to more work on. So in this assignment, the big concept again was, well, not again, but was complementary events and what that is. So complementary events, it says, are events that together contain all of the outcomes. Let me get rid of that line so you can see that. All of the outcomes, or in other words, 100%, which is a number that is associated with the word all of the 100% of the outcomes. And that's the big idea. And so right away they go into, okay, number one, we're rolling a six-sided die, and you go back to activity 1.1. I didn't assign that to you because that was kind of a duplicate of what we did with the Khan Academy. And I'm trying to mix it up a little bit so you're not doing too much in the book, but we're kind of going back and forth. So we're rolling a six-sided die, not dice. That would mean more than one. That's plural, but this is die. So we're rolling this six-sided die, and it says we want to know about the probability of rolling an even number. And I know you know your even numbers, but I'm going to put these down here. So we got 2, we got 4, and yes, we got 6. There they are. So that means for the probability of rolling an even number, there are 3 possible desired outcomes. Out of, or divided by, my total number of outcomes, well, along with these, we have the ones that fit in between there, right? We got our odd ones that we're going to get to in a moment, okay? Or not even, my complement to this. So there are a total of 6 possible outcomes. And I know that you guys are smart and you probably went right to this. You reduced that. And you probably then heard my last screencast when I said, you know what, normally in an everyday situation, we're probably not going to use fractions to talk about probability. Typically, we're going to use percentages. And you're going to see that more and more as we move on here. And so there's my, oh my gosh, that's an ugly percent, sorry. There we go. It's kind of like a tail or something, I don't know. Anyway, so we have 50% chance of rolling an even number. Well, then it says its complement is rolling a number that is not even. So here are my options for that. Here is rolling not an even, the complement again. And again, you see, oh, look at, there are 3 possible options, 1, 3, and 5. That's a total of 3 possible options. Out of, there are a total of 6, again, total possible outcomes. And I'm gonna cut right to the chase, go right to my answer is again 50%. Well, if you add these 2 complement events, again, we have the event of rolling an even, and then the complement to that is everything else, which would be not even, so all the odd ones. If I add those together, there is all of the outcomes. It has to equal 100%, the whole thing. And again, that is the big concept that we're going to keep coming back to during this little screencast. Okay, so let's go down here. Question 2. So now we're saying, okay, we're going to roll a number greater than 4. So number greater than 4, well, that would be 5 and 6. Those are my only 2 possible desired outcomes. Out of, there's a total of 6, again, possible outcomes. Well, how do we get 6? Well, there we have these 2, but then we have everything before those 2. So we have 4, we have 3. Oh my gosh, I'm counting backwards. This is amazing. 2 and 1, but I can't write very straight backwards, evidently. And if I add those up, I have a total of 4 total possible desired outcomes. So all the ones that are less than or not greater than 4. And those are the ones that are my complementary events. And some of you might have gotten stuck on this one because it's kind of, tricky. It says not greater than 4, and you might think to yourself, oh, that means 3, 2, 1. Well, 4 is also not greater than 4, so we have to include 4. So my total number, again, of events is a total of 6 that are possible. And if I add these two up together, and this time let's do it with a fraction. Oh, look at, they're already common denominators, which you already know that we need when we add fractions. 2 6 plus 4 6 is going to give me 6. 6. Oh, and what do you know? That, once again, is 100%, just like we got above. 100%, all of the outcomes. Okay, again, the big, big number of the day. And as we move forward here, oh, here we go. Question 3. This was the question I was looking at that I saw some right responses, but I also saw plenty that showed me they were a little confused by this. And actually, someone even bravely asked it on the period 1-2 document, which is awesome because there were, again, a number of people that got that wrong. So I did put that response on that document, but now you get to see it in a little bit more detail. So it says, what is the sum of the probabilities of any two complementary events? So here, let me give you another event. For example, weather is on our minds quite a bit. I know my dad loves to watch the weather forecast every day, and he watches it for a month out and will tell me what it's going to be like in June, even though we're in January, and somehow thinks that's going to be accurate, but we know it's not. But let's say the weather for tomorrow, let's say that there is a 30% I can't even talk anymore, percent chance of rain. Well, what would be the complement to that? Waiting. Yep, I think I heard it. So that would be not rain, right? Which means that would be a 70% chance of anything but rain. And if I add those up, it's always going to equal 100%. And another way of writing 100% as just a decimal is 1. Which means the whole thing, all the possible outcomes have to equal 100%. It's guaranteed that one of these things is going to happen. Either it's going to rain or it's not going to rain. Guaranteed. Okay? And the last one I thought was a little bit confusing just on how they worded it. And we're comparing Leah to Jasmine and the difference in these, but I want to explain what this means first of all. So first of all, it says the probability of not a 5 or less. So not a 5 or less. Okay, which is kind of confusing because it's like, okay, what do they mean, not a 5? So what they're saying is, well, if I do a 5 or less than 5, so 4, 3, 2, 1, that is not, we want not a 5 or less. So we do not want 5, we do not want 4, we do not want 3, we do not want 2, we do not want 1. So the only thing remaining is a 6. And there's only 1 6 as a possible outcome out of a total of, let me erase this so you can see this and blow this up a little bit. Out of a total of, notice there are, again, 6 possibilities. Man, and once again, I just wrote right over it so you can't even see it. All right, anyway, hey, thumbs up, nice. All right, get out of there. Okay, so hopefully that made a little bit more sense because I know some people were a little confused in that. So Leah just went right to, okay, this is the option that we're looking at. She went right to the answer. I think much more efficient method. Okay, Jasmine, however, did a little bit differently. She said, now where did she get this number 1 from? Well, 1 represents, remember, 100%. That represents all of the possible events. That means I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay, so that's what that 1 means. Then she said she's going to take off all of the ones that we don't really want, the 5 or the less, which is the 5, 6. Now you can see why she put it as the number 1 here and not like I did 100%, but I just wanted to make sure you understood that's where that 1 really represents. That's all of the possible events. So she's taking all of the possible events minus, well, there are, as we said before, 5 possibilities. There's this guy, we don't want this guy, and we don't want anything less than that guy. And don't ask me how I know that that's a guy, because I don't know. Maybe it's not. So there we go. We got 2, 1. There we go. So there's a total of, there's my 5 possible outcomes right there. And if I subtract those, notice I get the same exact response as sweet Leah did up above. And so the difference between them is, I mean, it's pretty straightforward. They're looking at two different things. Leah is going right at, what do we not want? She went right to it. Whereas Jasmine took a little bit different route. She subtracted the 100%, all the options, minus the ones that we didn't want. Okay, they're 5 out of the 6 that we didn't want to get the one. So she went a little bit different route. Both work, but obviously this is the one that's going to get you that job. Way more efficient and going to cost less money in the end for whoever's hiring you. So hopefully that made sense. And once again, I hope that you had fun doing this assignment because math is fun and you know it. I look forward to hearing from you again as we continue on. And again, I know this is a strange way of learning for many of you, but we're going to get through this. And again, I know we are going to be stronger for it. Take care, guys, and hope to see you soon.